But Dr. Rick Selby is the Director of Engineering at Northrop Grumman in the Aerospace Systems Division or group at Redondo Beach. He's also the Adjunct Full Professor in Data Sciences and Operations Department at the USC's Marshall School of Business. He got his PhD in Computer Science at the University of Maryland in 1985. Since then, he has authored, I was looking at his CV. I mean, it is unbelievable. 135 papers at least, multiple books. He's been an invited speaker both to conferences and on the media. So Rick has been a friend of the centers, or has been part of USC CSSC for, well, ever since the COCOMO book came out. He knew Barry before then. I met Rick during the COCOMO modeling time in the late 90s. He's a co-author of that book as well. Been a great friend of the center, and he's a friend of mine. And I really am very honored to have him speak today. One of the reasons I wanted to mention, he authored a book, or edited a book called Software Engineering, Barry W. Bain's Lifetime Contributions to Software Development Management and Research. And there's lots of Barry's articles in that book, and Rick did an amazing job at arranging these into different sections of Barry's wide span of interests in engineering. And I would really, I really appreciate him speaking today. And without further ado, please welcome our keynote speaker, Rick Selby.
Great. Thank you very much, everyone. So once again, Brad, thank you very much. So Julie, I think I'm gonna send my slides to you. And if you could just screen share and I could speak, that would be great. So I'm gonna put my slides into the chat to Julie. Okay, Julie, can you please help me in that regard? Okay.
Yep.
So one quick second here.
Got it.
Okay, excellent. Thanks very much. Well, Julie's bringing the slides up. I really appreciate the opportunity to give this presentation today. You know, all of us have been friends of Barry for, you know, a long, long time, and the new organization will continue to really, you know, keep his, you know, vision and ideas alive, and really benefit, you know, quite a few people and organizations and just in all kinds of different ways. So what I tried to do here is really summarize some key contributions from Barry. And what I want to do, the slides are coming up. What I want to do here is really share not only some summaries of Barry's contributions, but, you know, some things that I've seen in terms of the impact of Barry's ideas. So Julie,
I don't know what you see.
I don't quite see the full screen. Just go into slideshow if possible, please.
Use slideshow. So in theory, I'm sharing this.
So can everyone else see?
Nandi, what do you see?
I just see the left half of the slides.
Yeah, I see that as well.
Not showing the whole thing.
Okay, give me a second here. We share.
Have that outstanding question.
We share
Excel file. I know Dave was interested in.
If you just did what you did before, at the lower right, there's a little symbol. Looks like a sort of a TV kind of rectangle.
Yeah, if you do slideshow, I wonder if it might do the right
But I think what it's
view.
doing is that it's putting me into a different setup. So
Now I see the right half.
that is weird. That is very strange.
All right, I can see it now. I can
Yeah.
see the full screen now.
Well, you can see you're seeing the wrong thing. You guys are seeing, because now it's just taken over my entire computer. Like it's taken over everything. So hold on, sorry about this.
Just one suggestion is at the lower right there, right by that slider bar. Just go to the left. No, not that one. Left. Just that. You just passed it. Just that one. Click that one, please.
Yeah, because right now I have the main thing on two different monitors right now. So
Okay.
that's what it's doing. So I'm gonna actually close it really again.
That's okay. So while Julie's getting that set up, I just want to emphasize that as Brad summarized, I think the new organization is going to provide a unique opportunity for collaborations to continue, and whether the form is individual organizations adopting ideas, students at universities, decision makers of any kind, benefiting from his ideas. I think all those opportunities exist. So we look forward to that. I just want to say that I think the organization is going to be very successful.
Really quick. So Anandi, I won't know if can I drop this to you really quick, because my computer is not handling this file for some reason. I don't know why.
Okay,
Sorry about
Thanks,
that.
thanks, Julie. Thanks, Anandi.
no
Well,
worries.
that's coming up here. I enjoy seeing all the faces on the screen here. So for many years, of course, we met in person, and then now meeting virtually is lots of fun. So
Hold on, share. Rick, you may want to go ahead and just drop it back into the main chat so Anandi can pick it up quickly.
okay, do exactly that.
Thank you.
Okay, Nandi, you should have the slides.
Got it.
Might be a little background noise from someone. Please.
It's probably
Sorry, that's
it's Anandi.
that's
Sorry.
me. I'm multitasking.
We all are. Thank
Okay,
you.
excellent.
Perfect.
Okay, Anandi, Julie, thanks very much. So everyone should be able to see the screen here. What as I briefly mentioned earlier, I've tried to really collect together what I think are significant contributions from Barry, but I will emphasize that there are so many contributions that really being comprehensive and including them all is a really challenging task. So this is a sampling of the ones that I just wanted to share with the group today. On this title slide here, what I wanted to do is, this picture is of Barry. It's actually at the symposium that Brad mentioned earlier. In 2017, we had this recognition event where many of Barry's circle of colleagues attended. This meeting is actually in Minneapolis, Minnesota, to summarize his lifetime contributions. And there's Barry at that exact meeting. And this photograph is particularly meaningful, I think, to all of us. Why? This is how we remember Barry. Okay, he's giving a presentation, having a tutorial. He's working with students. He's helping collaborate and disseminate his ideas. Okay, next slide, please. Okay, so briefly, I put together a summary of Barry's career, and then I'll go into more detail into his contributions. So Barry was the Tier W professor of software engineering at the computer science department at USC. He's also, of course, the director of the Center for Systems and Software Engineering. He was at USC since 1993. Prior to that, he was at the Department of Defense as the director of the DARPA Information Science and Technology Office, and also director of the Defense Research and Engineering Software and Computer Technology Office. So in that role, he had the ability to fund a whole variety of research and shape a tremendous amount of policy decisions in system development and acquisition. So before that, he was a Tier W, not quite, thanks. Before that, he was at TRW for many years, and the foundational work at COCOMO among other research he did at TRW, working with actual systems. And before that, he was at Rand Corporation. Now, Rand, I really think provided a very unique opportunity to see a wide variety of systems and how they were developed, and really start to harvest best practices that really sparked, I think, a lot of insights and ideas that he shared, throughout his career. And then in terms of education, Barry went to Harvard. He got his BA degree from Harvard in 1957, and then his MS and PhD from UCLA, all in mathematics. And on a personal note, I studied math as well extensively. My undergraduate degrees in mathematics, and the interplay between math and computer science and systems development, and then ultimately decision making and leadership. I think you can see the roots in Barry, and it's very, very inspirational. Okay, next slide, please. So the in terms of what he did at each of these organizations, I briefly mentioned those, but just to emphasize a few. Of course, at USC, bringing together the collaborative nature of system and software development through the COCOMO forums, through the center, really helped not only communicate ideas, but it helped build the community. All of us, of course, were active in those meetings and interactions, but you felt connected. Okay, you felt part of the community, and of course, Barry was the leader and enabler. And at DARPA, as I mentioned briefly earlier, but in terms of funding, but DARPA, I think, provided an excellent example of how software research in particular, systems research, was an enabler. Okay, software is obviously pervasive here, but Barry's role at DARPA was at a particularly important time where lots of risks, lots of opportunity, lots of value creation was all intersecting through software. And the leadership he provided there, I think, was tremendous. DDR&E, there are lots of good things there, one of which was helping with a capability maturity model work in terms of really helping people understand the need to improve their organizations, as well as very standard work. At TRW, he was directly involved in system development above and beyond, helping lead the organization. And this bridging between actual systems and the research, systems development and research, I think, is particularly big lever for setting an example on software and systems research. Okay, so in other words, being grounded in originating new ideas and applying those ideas to actual systems. So TRW, I think, was an excellent forum for him to bring all those ideas together. And at Rand, one of the early studies that Barry did was on the command and control information processing study, and it really set the tone for how we'd approach analyzing where things were working and things were needed some opportunity for improvement, and how to disseminate those. So next slide, please. So with all that said, Barry contributed in many ways organizationally to the broader community, above and beyond his primary role at a company or organization. Served on many scientific journals on the editorial board, IEEE Transactions on Software Engineering, IEEE Computer, IEEE Software, and so forth. And serving on these academic journals provides sharing of his ideas in an effective way that helps others get their work published, and he provides feedback and helps set overall direction. So very, 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 very helpful. And he shared a whole variety of incredibly impressive organizational entities, and you can see the list here in terms of these roles provide really helping shape others' directions and organizations' decision making. And just to mention a few, the governing board of the IEEE, the Computer Society, really is with the ACM among other forums. These are primary publishing venues for all of us, and the support of these professional organizations. For example, through the governing board, I think Barry really helped shape that, and was incredibly supportive. Okay, next slide. And then in recognition for all these contributions, Barry really was extremely widely recognized. And I just mentioned some of the many awards he received, and this evidence of his recognition of his contributions, I think, is really really impressive. Okay, so he lectured internationally, including the USSR. He won a whole variety of awards and prizes. You can see them listed here, including the Grace Hopper Award, including Department of Defense for Excellence, Lifetime Achievement Awards, distinguished awards from the Society on Quality. Harlan Mills, once again a collaborator, one of many collaborators, the award there through the IEEE. He was a fellow in many professional societies, ACM, AIAA, IEEE, and COSI, and of course a member of the National Academy of Engineering. So extremely impressive and very inspirational leader for all of us. So thanks for just allowing me to provide a little bit of an intro of Barry. So now what I want to do is go through a dozen or so of key contributions from Barry to systems and software, the world of systems and software. So next slide, please. So what I did is I started early. So in chronological order here, if you look early in Barry's work, you can start to see how he thinks about things, how he analyzes things. And on a personal level, I'll emphasize that his approach, I think, not only helped me, but I can help many, many others in terms of, well, how do you actually get your hands around, the opportunities enabled through systems and software? How do you get your hands around, what's working well? Where are there challenges? Where there's opportunity for improvement? And how do you capture that in such a way that's transferable to others? And really sort of magnifies the effect of the analysis. So it's not just a standalone analysis; it's a capturing of those ideas and dissemination of those in such a way that helps others. So, as an initial example, this graphic here, the graphic might strike you as very simplistic, the hardware software split, but I will tell you, organizations to this day are still digesting this concept that major functionality of their systems and their whole organizations is rooted in the software, and it's growing, and the flexibility you get with software to continue to rapidly innovate and disseminate new features, pre-delivery and post-delivery is incredibly important. But once again, tracing back to the early days, 1973, and providing this insight to the world, I think was particularly impactful. So the last bullet there, the initial emergence of cost as a key area of focus. He noticed right away that software costs exceeded hardware costs by at least 2 to 1. Okay, so once again, sort of planting that seed that software had a lot of opportunity. Okay, next slide, please. So another, as part of that same study, another element of it, and this goes to show his approach to really engaging with others and helping get his point across in a way that's very collegial. He came up, as part of that same study, he came up with a software quiz, and he gave this to stakeholders to really help sort of ask them insightful questions and calibrate their degree of understanding of what's going on in the software world. So just as an example, you'd say, well, of these development phases, where is the effort being spent, where errors being detected, and so forth. So next slide, please. Okay, so now moving on to his really foundational work in the area of software engineering economics. Okay, so you can see the book cover in the upper right there. So at a personal level, I was in graduate school, okay, and I remember my advisor was Vic Basili. I remember when Vic provided to me a draft of software engineering economics. Okay, it was actually printed. He handed it to me, and he says, "Take a look at this. This is some terrific work from Barry." I had not yet met him in person, but shortly thereafter I would. And once again, tremendous influence on me and many others. The book, of course, is extremely well known. It provides the basis for a lot of the modeling work and the fundamental approach to systematically analyzing software in a way that enables modeling, where the models provide a framework for decision making, for lots of people, organizations on the development side, organizations on the acquisition side, supplier side, and so forth. So the specific graphic here, this is the cone of uncertainty. The cone of uncertainty, I actually use many of these ideas in my system development and in some of the classes I teach. The cone of uncertainty, of course, shows us that early on, okay, there's a wide range on the left side of the x-axis there. There's a wide range in terms of the potential outcomes, whether it's cost or defect rate or value creation, market share, profit, and so forth. At the right-hand side, ultimately, of course, we know the answer. Okay, we know what happens, and the path from getting from that wide range of uncertainty to knowing the actual outcome is, it can be a very interesting journey. So the cone of uncertainty really, once again, is a great example of an economic concept that Barry applied to software development. So the bottom bullet there, fundamentally, if you look at, well, what was Barry trying to do with COCOMO and the modeling, is that and this is something I still encounter on a regular basis. Small companies frequently say, "Oh, we don't have enough resources to do what we want to do." But I will tell you, large organizations in general do not as well. Okay, even with these huge budgets on these systems, developers frequently, as well as decision makers, leaders of the system development, they don't feel like they have enough time or money to incorporate all the good features. So you're forever in this mode of, well, how do you actually focus on the value creation? And what should you do first? What are the features that really are needed by the end users? What are the features that are going to drive the system adoption and successful usage? So, and therefore needing a model in this in the spirit of something that's like COCOMO, that provides an interactive framework to not only sort of make cost estimates, but do all the sensitivity analysis and trade-off analysis that frequently occurs. Okay, next slide, please. So this table at the top, of course, is the set of drivers that have enabled next slide, please. The set of drivers that have enabled people to think about the analysis capabilities within that are enabled by COCOMO. Okay, next slide, please. Thank you. Excellent. Okay, we're on slide 8. Once again, the drivers at the top. Okay, this is not all the drivers, but the point is that these drivers, since we've added many over the years, but the concept of a driver. So once again, Barry's ability to bring tremendous clarity to a problem that he's trying to solve, namely, how do you make decisions? How do you provide a framework? How do you provide visibility to enable trade-off analysis, sensitivity analysis, and really approaches in a systematic way that uses data that can apply to a whole variety of organizations. That was, of course, crystallized in the COCOMO model and the many, many variants that have occurred since then. Okay, so PhD theses of many kinds have been extending the COCOMO framework to many different areas. But the fundamental concept of a model that uses a set of weights, multipliers, drivers that have both linear and nonlinear components to them, and determining the weights and seeing how the weights interact, and then actually calibrating them against a nominal of 1.0. I mean, the impact of this has been tremendous. Okay, so people can say, hey, this weight needs to be changed or another factor needs to be added, which has of course been done over the last many years. But the fundamental idea was tremendous. So now further beyond the primary use of cost here of these models, okay, Barry extended all of this into risk management, into the general practice of software management, systems management. So it's really much more than a cost model. It's a way of thinking about how to make decisions for not only feature selection, cost estimation, how it dovetails into scheduling, how it actually affects risk management, as well as overall, value creation. Okay, next slide, please. Now, what Barry did, what Barry did in terms of this analysis is looking at different contributions to the variance. Now, so one element that's a little less obvious about how the drivers work here is the range each driver provides. Okay, so of course there's individual drivers, there's numbers there, people, work with those numbers, but the point is there's different, ranges that each of them can impact. And a key conclusion, of course, right there on the cover of his book, is that the capability of the people that you have involved, the system development is, one of, it provides tremendous range. Okay. And so Barry has studied this in a whole variety of individual articles, as well as the book, of course. But really helping people understand you could optimize on certain drivers or drivers. But if the range of potential gain is not as large, you may not be using those resources as well as you could be. So really understanding above and beyond the cost estimation itself, above and beyond the overall framework, just understanding the ranges of the contributions and the impacts of these individual drivers, I personally found was incredibly effective. Next slide, please. Now, another topic that Barry investigated was the idea of reuse. So this example here, this figure at the top here, I would just emphasize above and beyond the details of reuse here, the degree of clarity and the degree of insightfulness that Barry brought to various topics. Now, I'm just going to read these here because if you read them, you say, hey, that sounds like it makes so much sense. Well, the reason it makes so much sense is Barry brought just so much tremendous clarity to the topic. And it's just one of his many examples. And once again, this is beyond, Barry, of course, well known in the cost area, but he's contributed in many areas. And this is in the area of reuse. Okay, so the overall goal, improving productivity. Well, what can you do? Get the best from people. Okay, make steps more efficient. Eliminate steps. Now, eliminate steps. I mean, whole improvement initiatives have been launched about how you can simplify your organization, simplify your processes. So eliminate steps. Once again, tremendous degree of clarity there. Eliminate rework. I mean, once again, consultant engagements and organizations are frequently focused on, well, let's find the rework, let's find ways to eliminate it, build simpler products and reuse, of course, as I mentioned. So a framework as simple as this, these 6 ways to improve is really timeless, okay, as is his other work as well. It really provides people a very structured approach to thinking about problems in a way that's extremely clear, and I think it's been incredibly helpful. Now, with the specific example of reuse here, I think helping people think about back to the ranges of productivity increase, reuse, as this one area. I think Barry emphasized this, and in system development that I was directly involved in, the degree of reuse we were able to achieve. Once again, it's largely inspired by Barry's ideas. Okay, next slide. Now, in the area of really trying to broaden his impact beyond beyond his early primary work and cost estimation, reuse, understanding systems, best practices generally. When Barry thought about the spiral model, he actually tackled an incredibly broad topic, like how can we think about software system development in a way that really, approaches the whole life cycle. So the spiral model brought to us the concepts of iteration, the concepts of concurrent work, the concepts of how do you actually embrace, not just sort of manage, incomplete information. Okay, so you have a system, you're building it, and early on, people talked about, we're going to have complete requirements. We're going to quote unquote freeze the requirements. We're going to we're going to have this sort of top-down mindset. And those ideas at the time, of course, were, had some degree of appeal. However, as you built and studied, large systems, you quickly came to the conclusion, and Barry articulated this, that you have incomplete information, things change. You need to deal with new opportunities throughout the life cycle. You need to manage risks, yet you still need to make progress, throughout that whole process. So how could you actually do that? So the spiral model brought to the community a way to think about these increasing spirals. Namely, early on you do something more modest, you make some incremental progress on that, but then over time, through more and more spirals, more and more risks are retired. Okay, there's incremental progress, there's greater stakeholder engagement over time, and then you ultimately deliver a system. Now, the graphic here really tries to integrate key life cycle objectives at the top. That's life cycle objectives, LCO, life cycle architecture, and initial operational capability. So I will tell you, when this came to life on real systems, the concept of initial operational capability was a really impactful way to think about it, because people would typically, once again, early on, this is decades ago, still to some extent today, people would think about these large monolithic development cycles that would take 5 years, longer, to get to like this initial sort of release. Okay, so this emphasis of moving the initial operational capability earlier, okay, so you can have more of an incremental development and create value sooner, and then obviously subsequent releases later. That was enabled here through this spiral thinking here. Okay, next slide, please. So now so in the chat there, really planting the seeds. Okay, excellent, Dan. Planting the seeds for a lot of the the agile mindset that exists today and has been around for a while. In other words, how do we actually deal with all this uncertainty, manage through all this frequent change, have flexibility in terms of delivering new capability. I'm trying to tie in some of the early thinking there that Barry provided that shaped people in many ways, one of which is agile, as Dan mentioned. So on slide 12 here, so Barry really was rooted not only in the practical system development, but had a theoretical dimension to his thought process as well. So he has several theories that he captured, and this concept of theory W really centered on win-win. Now, I've tried to emphasize here the impact that I've seen of these ideas, but win-win, even though it strikes you as incredibly simple, like what does it fundamentally mean and how did it impact organizations and projects? Win-win is trying to achieve wins for both parties in a decision-making interaction. So if it's a customer and a system developer, how can both achieve what they really want to achieve? The system acquirer wants these capabilities within a given budget and schedule. System developer wants to do all of that, but to do it in the context of a business, namely building the system through there's a variety of financial dimensions to it. Actually, for example, not losing money, but in most cases, of course, trying to earn a reasonable fee for doing so. But really, more deeply building a customer relationship that leads to more and more work in the future. So the win-win mindset, I will tell you, I've personally seen shape so many negotiations with suppliers, negotiations with customers, and fundamentally, it's just such a simple idea, but very, very impactful. So one layer of detail below that is this concept of success critical stakeholders. So the role of a stakeholder, so early on in terms of decision making, well, how do you make a decision? One of the first things you need to do, of course, is get involved you get the right people involved. So the concept of Barry's articulating who a stakeholder was, anyone who's affected, okay, by the system itself, its impact on legacy systems, its usage or impact in the future, in terms of decision making, usage, or interactions with, it's going to be a stakeholder. So success critical, potentially all those people, or potentially a subset, need to be involved early on in this decision making and leadership of system development. So just the concept of identifying stakeholders, success critical stakeholders, and bringing everyone into a win-win approach, incredibly impactful. Okay, next slide, please. Now, back on the theme of reuse here, but really emphasizing the role of data. Okay, of course, in the COCOMO model, the drivers, and a lot of the other studies that really brought in data as the accelerator to seeing the insight and then sharing in such a way that was objective and provided a basis for other people, to credibly make decisions here. So in this particular analysis, this article, Managing Software Productivity and Reuse, he looks at, how can you continue to increase your system size and system capability, and yet do this in a manageable way that avoids unfavorable outcomes and enables win-win success here. So various milestones on the x-axis there in terms of time, but your systems continue, of course, to this day and well into the future of getting more and more complex. How does everything interact? So how are we going to get our hands around this? So by zeroing in once again this concept of the potential gain from different steps that any decision maker could take. I mean, how can I improve my organization? How can I deliver more capability? Some key bullets at the bottom. So here's one option. You can work faster by using tools that automate or speed up previously labor-intensive tasks. There's potential gain of 8%, once again, captured through data analysis. How do you get to the 8%? It works smarter by process improvement, 17% gain. Okay, and they're not mutually exclusive, these options. Okay, and or avoiding unnecessary work by reuse. Okay, 47% gain or potentially even larger. So this emphasized, how people can make decisions using data, and of course highlights the opportunity through reuse. Okay, next slide. Now the framework of economics here, in terms of the graphics, really trying to continue to emphasize that if you look at software and system development, if we have people, we have time, we have computing resources, we have systems that we want to build that solve problems, really at the center of it is or one of the key elements at the center is this concept of economics. In other words, the study of trade-offs, the study of value creation, the study of really decision-making that focuses on maximum value for a given investment. So clearly, through the extensive modeling work that Barry did, he emphasizes the role of economics, but even broader, the mindset that people have about organizations, processes, decision-making, individual systems, company creation, and so forth, centered around economics and using systematic, approaches to leverage data to make decisions. Next slide, please. So now these graphics that Barry has provided, for all of us, and I've tried to capture some key examples here. This concept of the left-hand axis, you've got early life cycle activities, requirements, design, coding, and later life cycle activities. And if you could say, well, gee, there's defects that are going to occur, really, if we could find them sooner, okay, they're a whole lot easier to fix that, okay, because the later they occur, the later they either occur or later they're detected, the impact on the system, can be disproportionately large. Okay, so you actually have many more commitments that you've made later on. Okay, you've got users of the systems, you've got testers, you have other systems and other interfaces that depend on them. And if errors are discovered later on, the ripple effect to all those other parts of the system can be super linear. Okay, in other words, on the y-axis there, you can see the tremendous multiplier effect. So another excellent example of Barry's contribution to successful systems leadership is really capturing through data and articulating it and disseminating it so others can benefit. This concept of the later we find the defects, the more expensive they are, and the early, conversely, the earlier we find them, the whole significantly less expensive to fix. So this shifting of of software and system development techniques to focus on the early life cycle was driven by these kinds of analyses from Barry. Okay, next slide. So now another example I wanted to sort of emphasize here. I mean, these many, if not almost all of them, dovetail into one another. Is that Barry began to articulate roughly in the 2006 timeframe this concept of value, and it's really emphasizing principles that he had shared before, but really providing a greater emphasis on it. So the 80-20 rule is another example of something that's so clear, so simple, and yet Barry helped bring the emphasis on it to software and system development. So what is this 80-20 rule? So 20% of the system generally results in 80% of the cost. 20% of the system has 80% of the errors. 20% of the system has these various characteristics. So it's not a uniform distribution of functionality, uniform distribution of cost and risk and so forth. And the mindset that Barry continued to break down, he was breaking down the mindset that there's this uniform distribution of resource expenditure across the features and capabilities, because it just simply did not match the data that he and others were seeing in real system development. So in this simple example, of course, has to do with test cases. You need to understand what parts of the system to test first. Why? To reveal errors that are particularly important to reveal earlier, because you're finding those sooner is going to be a more efficient use of resources and get your system, your successful system developed and delivered sooner. So this concept of the 80-20 rule is one tenet of the value-based software engineering was once again tremendously impactful. Okay, next slide. So now in this family of ideas on value-based, Barry continued to introduce elements of theory, okay, to leverage and integrate ideas from different areas. So just at the center, he was continuing to try to advance theory W, the win-win, SCS, success critical stakeholders, but he was really trying to introduce key ideas found from other disciplines, okay, and just not only to illustrate that we can learn from other disciplines, but really trying to bring those into software and system development. So a great example of that is control theory. So in control theory, you walk into a system, okay, whether it's new or existing system, and there is some concept of a state that the system is in, okay, and the state can be stable or not. So in general, what you're trying to do is understand the state, and as one example of what you do is you think of it as a system under control, where control is defined by upper and lower control limits, and therefore that provides a basis for decision-making about systems, okay? Namely, the extent to which you break through the control limits provides indicators that either the system has changed or there's something that's anomalous. So there's a fundamental change in the process or organization, or there's some individual outliers that have occurred, all of which typically would lead to action. So the use of control theory as an example discipline brought into software and systems development to provide this thinking around, as one example, once again, control charts, upper and lower control limits, tremendously useful. And other ideas from decision theory, once again, looking at decisions in a broad way and the trade-offs there, the risk, the value creation, opportunity management, and so forth. So this is Barry's work in value-based software engineering. Okay, next slide, please. So the now another step forward in Barry's work was to really, how do you sort of capture all these ideas in a comprehensive way to help really the project at the whole level. So the incremental commitment model, looking at once again the integration of these ideas, and the center piece from the left to right there, where you've got an incremental mindset. In other words, we're going to deliver capability. It's not going to be a so-called big bang with lots and lots of money and time spent, and there's some big release at the end. No, we're going to deliver increments, potentially once a year. So early on, a lot of projects stabilized around annual releases. These days, people stabilize around quarterly releases and even faster. Okay, so you can have releases that can be 2 to 4 weeks, and in some cases, people actually release things in a matter of days or almost real time. So the mindset of an incremental release that was managed systematically with prioritized features that created the opportunity for flexibility to change your priorities over time. Once again, a tremendously impactful idea. Now, that's the center, left to right there. Okay, so at the upper right, you're planning for future increments. And the lower portion of the graphic is how do you ensure that what you're building is actually meeting the customer needs through formal systematic approaches for verification and validation, and in many cases, especially with large governmental acquisition authorities, provide adequate assurance and documentation that those capabilities are met. Now, there was really, quite frankly, concerns about like how do we continue to verify our systems in this incremental approach, and Barry helped systematize that through this this incremental approach, how we can actually incrementally deliver capability and while preserving the incremental verification of systems. And to emphasize the top once again, these are not standalone incremental releases. There's an overall plan to create either accelerate features from future potential plan releases or potentially defer features. Okay, so this flexibility of embracing change across an incremental delivery cycle and still managing it in a systematic way. These ideas were captured in the incremental commitment model. Okay, next slide, please. Okay, another graphic that I found was particularly useful is the following graphic. Now, a big step forward here, especially in large system acquisition. There's a variety of milestones that these large contracts tend to have. So how do you integrate the incremental mindset with these milestones at the top? And you can see Barry actually doing that. Okay, at the top here, and you can have all kinds of reviews here and how kinds of largely, quite frankly, sequential events here. But how do you increment an incremental approach with the sequential events there? And classically, we think about exploring system capabilities. How do you focus on value creation? What's your overall architectural approach, not only in standalone systems but across systems? And the incremental commitment model helped us. Now, another thing I want to emphasize here is at the bottom, you can see those little clever circles and risks and arrows and so forth. This was once again the key insight here was not only delivering capabilities, not only doing it in an incremental way, but how do we actually manage risk? Okay, risk is how you think about things that are unfavorable that could potentially happen. They have not yet happened. They're unfavorable events that have some kind of probability and impact to them. And how can we systematically manage these risks and leverage this incremental approach to do that? So the broadening here of by the integration of a life cycle with risk management, and the analogous topic, which is called opportunity management, like in other words, good things that could happen that have some probability and impact. How do you integrate those? So I think it was particularly insightful here, the systematic integration of risk management with this incremental life cycle development. Okay, next slide, please. So what I tried to do here, this is my final slide, and we have an opportunity for some general discussion for a few minutes here. So what I tried to do is say things that Barry did that were his approach. Okay, we've talked about his organizational roles, the awards he's won, the leadership through the various journals and conferences he's provided the community, and of course his contributions to research and software development, system development. But this last slide, I wanted to reflect on really more the approach that he used. And this is intended to really dovetail into the organization that Brad and talked about earlier going forward, that these are things that Barry did that I saw that were particularly important. And I think it certainly inspired me, and I think inspired a lot of people. So he studied actual systems. Okay, so he did not did not look at things in isolation. Okay, once again, his laboratory was focused on like looking at systems. Okay, and looking what was working well, and had opportunities for improvement. And this was, you know, fundamentally provided an accelerator for the ideas. Now, and then what he did is he would generalize an idea to enable transferability. So you might have a standalone study and it might be a wonderful thing, but most people will want to know, I mean, the people on that system will benefit from that, of course, but most people who are not in the system say, well, how does that apply to my environment? So Barry's ability to generalize the idea to enable transferability to other organizations, once again, an extremely critical thing he did. Now, an element of doing that is using data. So data was the subjective source of really capturing what happened, but capturing it in such a way that was clear. I mean, it was factual. Okay, and you, people will have opinions and, you know, different views, and that's fine. And having data as part of that discussion was particularly helpful. So the data existed not only as standalone data, but we built models. Okay, so Barry built models to really bring everything together. Okay, and that enabled reusability, and then enabled frameworks for making decisions. So, and then I've tried to emphasize, with all that said, I mean, he brought this high degree of insightfulness and clarity. Like the example I mentioned earlier, several, but the one I emphasized was on the reuse, and really like eliminate steps. Okay, make products simpler. And then the researcher's time was value. So hopefully in my remarks today, you could look at these studies, some of which occurred literally, you know, in the 1980s, and, you know, even actually earlier. And, you know, they're timeless. Okay, you can look at these articles, you can reread them, and you can still learn things. So Barry's ability to sort of capture things that really benefit not only the current community, but for people to for many years to come. Collaboration, of course, a key strength of Barry, in particular, bridging across industry and academia. So he's able to really be incredibly successful on the industry side, of course, in the academic world as well. And that's a very rare skill in order to be able to do that. Now, there's a phrase that Barry had used, this concept of convening power. And once again, this inspired me and I think many others. The convening power, like, what does that really mean? That means if you call a meeting, you have a workshop, and you invite, you know, key attendees to that. I mean, you know, tremendous ideas and sparks come out of that, and relationships, you know, new ideas, validation of existing ideas, things like this. So this concept of, like, you know, harnessing and enabling this power to convene people, to bring together, once again, very, very impactful. And then engaging with openness. Barry, of course, is known when he touches, you know, people, and notably, you know, people that might actually have different views than Barry. Okay, Barry was remarkable in terms of preserving his openness, and really embracing many points of view there. So I think we've all been touched by that. And then finally, the overall leadership and objectivity Barry brought was tremendous. So with all that said, Brad, maybe we can take a question or two or further discussion. I know we have many excellent presentations coming up here. So just want to turn things over and open the floor up if there's any questions or comments that anyone has to share.
If anybody has a question or comment, if you could type it in the chat box, we can all see it. We can take a minute or two to respond to that. I mean, Rick, this is a tour de force. I'm just blown away. I didn't realize the breadth of Barry's, even though he was my advisor and I've known him for a long time. It's just an amazing overview of his contributions to engineering. Really appreciate your work.
Absolutely. Okay, thanks, Brad. And then there don't seem to be any questions right now, but I will tell you that I appreciate the opportunity to give this summary today. And of course, it's all due to Barry, and these, you know, the ideas come from him. I was privileged with the opportunity to you know, get to know him and work with him on some of these activities. And I just want to just, you know, emphasize that I think the new organization going forward, I think it's going to be very successful and continuing to collaborate and disseminate these ideas. So I want to be sensitive to the schedule here. I just want to transition things back to to Brad and Julie and Anandi here to continue with the program for today. So thanks very much.
Thank you, Rick.